Yep, question number 12. We have done a similar question yesterday, but let's find out. Question number 12, first of all, let's try to identify the hemisphere here. The hemisphere is not given, it's just given A and B on parallel of 30 degrees. You can add 30 degrees north there. It has to be given in the question. It's not there. So you can add 30 degrees north in the question. Therefore, the hemisphere is northern hemisphere.
Northern hemisphere. Sir, in question paper, like in Dgca exam, will it give the questions like this in which the hemisphere is not sure? So means there are chances that it may give me the questions like previous ones in which the hemispheres are not sure.
Yeah, yes. Oh yes, those are actually, all these questions are previously asked questions. The values might be different, but the model is almost the same. Yeah. Yes. So A and B are parallel of 30 degrees north. Great circle bearing of B from A. So it's B from A. So much? 84. 84 degrees true. Longitude of A is given as 174 east. You have to find longitude of B. So what's the whole idea here? You are given the hemisphere by specifying the parallel of altitude. Both A and B are on parallel of 30 degrees north. Great circle bearing from A to B is given. Long of A is given. You have to find long of B. So the hemisphere is to identify first, which is northern hemisphere. Therefore, we will draw the meridians like this.
And one alone parallel of latitude.
So both A and B are on parallel of 30 degrees north. So let's draw that here. Now, just like one of the previous questions which we did yesterday, you won't be able to place 174 degrees east straight here because you don't know what the other one is. So depending upon what one of the other meridians is, the location of this is going to change. Let's leave it there for now. We are trying to find out the locations of A and B by looking at this angle with respect to the true direction system that we have, right? So north,
northeasterly,
south, east, west. Yes, that is the northeasterly direction, 84 degrees. Somewhere here. Therefore, the center is always from A to B, and this angle measured from the north clockwise is 84 degrees true. Now I take this line all the way straight and bring it here. Same here. So you can see this is these 2 points. If I join these 2 points straight, that is the great circle track between these 2 points. Let me just draw this rhumb line track a bit more curved to have some space, otherwise. Yeah. So we saw yesterday that since the meridians are straightened, the parallels of altitude, they have to curve to kind of cut the meridian at 90 degrees. Right. Yes. Now, what is 84? 84 is the great circle track from A to B. So where is A now? A is to this side and B is to the
east to the west. Yeah.
That's right. A is to the west. B. See, this is another technique by which you can fix your longitude. If one of the other one is not given, right? So now the longitude of A is 174, which means
174 east.
That's right. So 174. Now the next thing you can do is look at the options and try to find the answer. You have to find out the longitude of B. Remember, the long of B is going to be to the east of 174. Therefore, the value is really going to be more than 174. So any options with a value
174 or the west.
It will be to more than 174.
Okay.
Because it's towards the east of 174, 175, 176, anything, or cross 180 as you said towards the western hemisphere, right? But all the options where it is less than 174, you can neglect it straight, right?
Yeah.
Perfect. Now the whole idea is I want to find out this longitude here. If I have one of the longitudes and if I do find the other one, the parameter which is connecting these two longitudes is the change in longitude, which is Chilong. If I can find the Chilong, then I can find the other longitude. And how can I find the Chilong? 3 ways of finding convergency: equation, difference in great circle track, using conversion angle. So here, if you look at the equation of convergency, what is that? Convergency in degrees.
Chilong in degrees is equals to Chilong in degrees.
Chilong in degrees
Multiplied by sine of mean latitude.
Sine of mean or middle latitude, correct? Yes. So if I can find convergency and if I can find mean latitude, then I can find Geelong. What is the mean latitude here?
It's 30 degree north.
Both A and B are on the same parallel of latitude, therefore the mean latitude is 30 degrees. Right? What about convergency? How will you find convergency here? You are given great circle track from A to B as 84. From A to B, the great circle track is 84 degrees. Yes, I'll give you some time. Find out the conversion again. If you want to find convergency, think about the three methods to find convergency. First is by using the equation, which you cannot do here because Geelong has to be found out. Second is by finding difference in great circle tracks. The second great circle track is not there. The third way is by using conversion angle. Conversion angle is also not there.
So since they are on the same latitude, now we got it.
Yeah.
The rhumb line track will be 90 degrees.
The parallel of 30 degrees north itself is the rhumb line track. Right? So since point A and B are on the parallel of 30 degree north, the parallel of 30 degree north itself is the rhumb line track, and therefore the angle of intersection of the meridians with the 30 degree north parallel latitude will be 90 degrees.
90 degrees.
Right?
So
Therefore the rhumb line track from A to B is equal to 90 degrees true. And what does that give you?
That gives me the conversion angle of 6 degrees.
So it's the difference between rhumb line track and great circle track here, 6 degrees. And yeah, so once you have the conversion angle has 6
I
degrees.
can calculate convergency.
Yeah, convergency is equal
to 12 degrees.
2 times conversion angle, which is
Yeah.
12 degrees.
12 degrees.
Right? So applying that there, Geelong,
So 12 degree equals to Geelong in degrees.
degrees is equal to 12 degrees
Sine of 30 degrees.
divided by sine of 30. That is
Geelong is 24 degrees.
24 degrees, correct? Geelong in degrees is 24. Now yes, Geelong is 24 degrees. To the east of 174 degrees, 24 degrees will be?
Yeah, so it will be like 14 degree west. Like 14 degree west means 180 minus 14 degree. 180 minus 14. 166 degrees west.
How much? 180 minus how much? You're traveling 24 degrees from 174.
174 east. Okay, sorry, I have written 170 east. 174 degree east.
Just cross check with the question. Is it 174?
Yeah, it's 174 only. I wrote it by mistake.
So what's the Geelong of B?
It's 162 degrees.
Degrees?
162 degrees west.
West.
Yes.
Right? Anytime you're confused with Geelong, always make sure you draw the top view and finding that's the easiest way to find out Geelong.
Yeah.
Right? So next time when you see this both points on same parallel of latitude, think about rhumb line track. They will not give you rhumb line track in the question then.
Yeah.
You see how you got stuck? This is exactly what will happen if you're not sure about this. Right?
Yes.
So it's when you picked it up, good. Alright, so before we look at the question, let's look at the scenario here. Northern hemisphere. I'll still make you think about the question. This is a different thing. North pole, this is the equator, and 2 points P and Q. If I draw a straight line joining P and Q, that's going to be the great circle track, and I can draw the rhumb line track like this.
Yes.
No.
The bottom side. Yeah, bottom side.
Rhumb line track. Yeah. Now let's look at these meridians here. Say for example this is 10 degrees west and this is 10 degrees east meridian. Right? And point P, parallel of latitude is 30 north. This is 40 north, northern hemisphere. Right? If I draw a meridian here, which is 0 degrees, and if I ask you to find out, so the great circle track from P to Q is 60 degrees.
Okay.
Right? And yeah, so you can you find all other angles for me? Great circle track
I can.
from P to Q is 60 degrees. Right? What's the great circle track at Q? How will you find out? So great circle track at P will change at great circle track at Q by an amount equal to convergency. So we have to find convergency first. Right?
But to find convergency, we need okay, change in longitude multiplied by.
So what is change in longitude?
It's 20 degrees.
You keep in degrees itself, don't convert to minutes. Multiplied with sine of
multiplied by sine of mean latitude.
30 plus 40 by 2 is 35.
35.
Right? Find out.
20 into sine 35 is giving me 11.5. Like it's 11.47. 11.5.
11.4?
Yeah, 11.47.
Yes, 11.5. Perfect. Now, if this is 60, northern hemisphere, you're going in the easterly direction, great circle track is going to increase by an amount equal to 1.5. Therefore, what is that going to be?
71.5 degrees.
I'm going a bit fast here because you know all those things, so the basic idea, right? 71.5. So great circle track at Q, the final great circle track at Q is going to be 71.5 degrees, right? What about the rhumb line track from P to Q?
Rhumb line track from P to Q.
Yeah.
So since we have convergency, so we can directly calculate the conversion angle.
Yes, very good. That's it. So whenever you have a great circle track and you are confused with rhumb line track, always apply conversion angle, right? So what's conversion angle?
It's 5.75.
Half of
11.5.
11.5 is 5.75.
75.
So I'll take it 5.7.
Okay.
Only will take 5.8. 5.8 degrees. Therefore, what is the rhumb line track? It's
68 decimal 5.
65
decimal 8.
And what about rhumb line track at Q?
It will also be same 65.
That's right, 65 decimal 8. That's with rhumb line track. Alright. What about the great circle track at the 0 degree meridian? So that is from the local meridian measured.
Yeah. So it is the total difference like the mean of the change like 60 degrees plus 71.5 divided by 2.
That's right.
65 decimal 65.7.
So how do you put that in statements? Is the great circle track at the mean meridian is the mean of the great circle tracks of the meridians under consideration. Or if you have to find out, you can still find out using that. But see, so what is the great circle track at mean meridian, say A? So great circle track at A is equal to 65 plus 71.5
divided by 2. It's 65.75.
65.75. I'll take it 8 again.
Okay.
Right? What is this equal to? 65.8. Is there any other angle that is 65.8?
What is this angle equal?
So what angle is this? This is the great circle track at the
track mean meridian.
It's equal to. What is the 65.8? Have we found out 65.8 elsewhere here? Any other angle having the same value 65.8? This is 65.8.
Yeah.
Any other angle with the same value 65.8?
No. Won't be. Okay, a rhumb line. Yes.
That's equal to your rhumb line track. So what is the rhumb line track at the mean meridian?
It is 65 decimal 8.
That is this angle.
Yeah.
Rhumb line track at mean meridian is this angle, which is
65.81.
Because that's not going to change. If it is 65.8 here, it's going to be 65.8 everywhere, right? So what can you say from here is that the great circle track along the mean meridian is equal to
equal to the rhumb line track.
Rhumb line track. Which means if I know the rhumb line track at P or Q, I can automatically say that the great circle track along the mean meridian will be also equal to 65.8.
Yes.
Or what you can see, if you look at these two pens here, and let me run these pens through rhumb line track and great circle track. See how the track changes. The great circle track in the northern hemisphere starts at an angle more than the rhumb line track in the northern hemisphere starts at an angle more than great circle track. It becomes parallel at the mid meridian, and then it becomes less than the great circle track at the other end.
Yes.
Right? If you take the opposite journey here, you can see the great circle track is actually more than the rhumb line track. It becomes parallel, and then the rhumb line track becomes greater than great circle track.
Yeah.
See, so mid meridian.
The point where it comes parallel is actually the main meridian.
That's right, exactly. At the mid meridian, if I take a direction here, it's going to be parallel.
Parallel.
Right. So later in charts, we'll also study that there is one more track called straight line track. Along mid meridian, straight line track, great circle track, and rhumb line track are all parallel along the mid meridian. Right. So there's something else called straight line track and great circle track. In Lambert's chart, great circle tracks are near straight lines, not perfectly straight lines. But the difference is so less, which we'll prove later. We consider them as straight lines. All right. So you can actually note this down. As an example itself, you can note this down and mark this. The great circle track along the mean meridian is equal to rhumb line track. And all these things is with respect to a particular direction. You have to travel in the same direction. Not great circle in that side and rhumb line opposite side. Both has to be the same.